going to evaluate piecewise functions and find domains, which is something we've been working on already. In this section, we tend to use the interval domain as opposed to the set builder. So you'll see more interval domains and ranges. Okay, so what is a piecewise function? So mathematicians are a very literal group of humans. So typically when we name stuff, we name things very literally. My mom used to joke that she could tell that that's kind of where I was headed in life. So when I was little, I had a blue duck, a little stuffed blue duck. Its name was Blue Duck. And then I had a stuffed pea bunny, and its name was Pea Bunny. And so we call these piecewise functions because they are functions that come in pieces. So again, I kind of fit that mathematician mold that like we call things what they are. We're not trying to like confuse you with the name. Like the name tells you a lot of what you need to know. So a piecewise function is something that is defined by different formulas. And I feel like the word formula is interchangeable with equation. Over different domains. Meaning, I'm going to tell you where to, or I'm going to give you some different equations to graph, and they're going to kind of make up the graph. It's almost like a Frankenstein graph. So there's going to be a piece here, a piece here, a piece here that go together, and I'm going to tell you where you're allowed to graph each one. When I think of piecewise graphs, one of the things that I think of most is thinking about like the stock market. If you've ever seen a graph of how the stock market's doing. So it's up, right? And then it's down. And then, ooh, it's flat. It kind of levels out for a minute. And then, whoa, it increases exponentially. So this would be an example of a piecewise function. So we could have an equation for this piece, and the domain would be from maybe like 1 to 3. And then we would have another domain for the piece that's decreasing really quickly. We would have another equation here for the part that levels off, and another equation for that piece as well. So you can see how they're graphed over different chunks. Okay. Here's what a piecewise function looks like. So if you are hearing the words that you're like, I don't really remember what that is, this is what they look like. So it gives you multiple equations, but they only live in certain spots. The first thing I want to talk about is evaluating. So evaluating means plug in the value. So let's start at f of 1. So we're going to plug in 1, but the question is, well, where do we plug it in? So we've got to decide which one. Is 1 smaller than or equal to 3? Yes. So that's where I plug it in. So it fits here because 1 is smaller than or equal to 3, so this is where I plug the 1 in. So I get 3 minus, and again, I plug that 1 right in. Well, what is 3 minus 1? 2. So that is my answer. So you need to figure out what part to plug it into, and then actually go ahead and plug it in. Next, f at 3. Is 3 smaller than or equal to 3? Yes, so I plug it in here again. So 3 minus 3 gives me 0. Now, notice that once I plug it in, I don't go looking to see if I can plug it in elsewhere. You're only going to be able to plug these in one spot. So once you find that spot, plug it in, and then move on. You're not going to be able to plug it into multiple places. All right, f of 5. Is 5 smaller than or equal to 3? Is 5 bigger than 3? So this one gets plugged in here, and I'm going to square it. Whenever you plug something in, kind of like what we were talking about last chapter with the quadratic formula, how you want to plug it in parentheses, same thing here. It needs to get plugged in parentheses. If I take 5 and square it, I get 25. And that's all you need to know for that group of problems. So So you're just taking it, you're figuring out where to plug it in and plugging it in. Now, some of the problems are actually almost so easy they're hard, if that makes sense. I'm sure you've all encountered things like that in life before. It's almost so easy it gets complicated. Write down this piecewise function for me. So for this function, these are two horizontal lines. So if I'm at negative 2, this means y equals negative 2. That's a horizontal line at negative 2. This is y equals 5. It's a horizontal line at 5. But again, it's over a defined domain. So I'm only at negative 2 when my x values are less than or equal to 0. Now, last time, do you see how we had x's that we could plug into? Okay. So when I go to plug in negative 1, first of all, let's figure out where it lives. Is negative 1 smaller than or equal to 0? Yes. I go to plug it in, and I can't. There's not a spot. So what would I put for my answer, do you think? Negative 2. So again, it's almost so tricky. They're almost so easy, it's tricky sometimes, because it's like, well, what would I plug in? So if there's no spot to plug it in, then you just figure out where it lives, and you would write down that value. So is 4 smaller than or equal to 0? Is it bigger than 0? Okay, so we would plug it in here, except, there's no spot to plug it in, so what am I going to write? 5. So again, some of them are just that easy. Alright, another thing that we need to be able to do is evaluate when we're plugging in more complicated stuff. So far we haven't been plugging in super complicated stuff. We've plugged in 4. That's pretty simple. What if we want to plug in a plus h? So we want to take that whole thing and plug it in. So let's do that. So this one's trickier in that way. We don't have to figure out where to plug it in. It's going to go in for every x that we see, but we do need to plug this whole thing in its place. So in place of the x squared, I'm going to put a little parenthesis house. In place of the x squared, so the x lived in here, right? I'm going to plug in a plus h. So where the x lived is now going to be an a plus h. So again, I like to plug everything in parentheses because then that helps. If you have something negative and you're squaring it, it kind of fixes that situation too. So here's my 3, here's my squared, here's my 4, this is where x was, here's my minus 1. So see how everything's still accounted for. In the parentheses is where you're plugging in your values. And we are going to simplify this out. Okay, so let's go ahead and do that. Remember, order of operations still applies. So this is a plus h times a plus h. This one I can simplify super easy. That's going to be 4a plus 4h. And then I've got this minus 1 that's kind of easy to forget about because there's nothing we need to do. It's hanging out there at the end. Alright, I'm going to FOIL these. I'm going to get a times a is a squared. AH plus AH. How many AH's do I have? Bless you. 2. It was almost like you said it as you sneezed. 2. Yes, 2. And then h times h, h squared. Plus 4a plus 4h minus 1. And again, remember that I typically tend to do extra steps to really bring home the point of what we're doing. If there are times where you're like, but Miss Bethel, I could have multiplied and also distributed the 3, that's fine. Sometimes I just take it a little bit more slowly so I don't lose anybody. I'm going to distribute the 3 now. Yeah? What did I do? Oh, 2AH? Oh my gosh. I'm so sorry, guys. Thank you. Yep, we had 2 AH's and I said that and then I didn't write it. Okay, now let's distribute. That's going to help. Now how many AH's? 6. Okay. Okay. Who's 3a's buddy? It should be 3a squared. Gosh, you guys. It's a bad Friday for me today. Okay. Do I have any like terms then? No, I have none at all. Just kidding. I don't even need an arrow. This is done. We're done, and more done. I don't even need to go further. That is lovely. Okay. Boom, done. Moving on. The next one, we're going to plug in a plus h again. Then we're going to plug in a. And we're going to subtract. And then for giggles, we're going to just put it all over h. And this formula is going to come back to you at the end of the year. This formula is actually a part of finding the derivative, is where this formula comes to us from. I can't use that color, that's ugly. Let's see, I'm going to grab a couple different colors so you can see where everything is. Alright, let's start here. I'm going to start by plugging in a plus h again. So I'm just going to deal with just that little bit. So let's go here and plug in just a plus h. And hopefully this time I'll do it better than last time. Here's a plus h squared plus 4. Here's a plus h. Here's minus 1. So again, I'm using different colors. If that helps you, join me. If it doesn't help you, you don't have to. So right now, all I'm doing is plugging in the a plus h. So remember, when we get stuff in parentheses, it's telling us to plug that in place of x. So we're substituting in something new. Then, I'm going to do this part next. Minus, and I'm going to use a parenthesis because I need to subtract all these things. I'm going to plug in a. So all that does is it changes every x to an a. So first I plugged in a plus h, then I plugged in a. And then do you see how it's just all over h? So it's just going to be this all over h. There's no spot for me to plug in h. It just would like an h please in the denominator, is what it's saying to us. So that's the color coding. That's where everything came from. So the h is just an h. There's my a. There's my a plus h plugged in. Alright, here we go. So this is going to give me, remember what we got out of here last time, a squared plus 2ah plus h squared. So I'm going to go ahead and distribute the 2 at the same time. So again, you might be able to feel like you can do more at once in some cases. So 2a squared plus 4ah plus 2h squared. Over here, 4a plus 4h. There's that 1 that's kind of easy to forget about because there's not much going on there. Let's distribute our negative. It goes to every term in this parenthesis. So minus 2a squared minus 4a plus 1 all over h. Okay, let's look for like terms. Ooh, this time we have some. What can cancel? There's going to be some canceling. Bulk canceling. The 2a squared. What else can cancel? The 1s. The 4a's can also cancel. And so I have 4 ah's left plus 2h squared plus 4h's all over h. Now, if I'm looking at this, I can actually do one more little itty bitty thing. What can I still do to simplify this? Yeah, I can divide an h out of each of them, can I? So if I pulled out an h, you can either think of it as factoring out an h or just dividing everything by h. Either way, same thing, tomato, tomato. But I'm going to go ahead and take away an h from each of these. and that means my h in the denominator is now just a 1. So I get 4a plus 2h plus 4. And that would be my final answer. Again, if you don't like thinking about it the way I did it, you could factor an h out front and then cancel it with the denominator. I think that looks a little bit nicer when you do it that way, so you can really kind of see where it came from. Okay, flip when you're ready. I'm going to give you a minute in case you're not. Yeah. Yeah, this is this. So this is me just plugging in the a in place of an f. So the entire equation, this is the whole thing we're looking for. We want this whole piece. This is me plugging in a plus h in place of x. This is me plugging in a, and then this is me just writing the letter h. Okay? Alright. Flipping. Again, like I said, this is why this packet is so large, because I had to front to back it, because some pages were front to back and some weren't. Okay, we're going to cancel out that top example. We're going to head into domains, and then we're going to do one application problem. So we actually only have 4 more examples that we're going to do before we head on to homework. Okay, I'm going to give myself some spaces to work. You'll notice I like to write everywhere, so I got to give myself some boundary lines here. Okay, we are looking for domains. Now, when we're looking for domains, do I have, oh I do. I made it a red flag. We know what red flags are, right? Warning. Okay, what's a red flag? What's something that would give me an issue with my domain? If what was 0? If the denominator was 0. So if we have a fraction, that's a red flag. Why? Because our denominator cannot equal 0. So that's one of my red flags. So I'm thinking about a domain, red flag, denominator can't be 0. There's one more type of red flag. My flag is getting really large, so I can write all the things in it. What's the other thing? If we don't want to live in imaginary number lands, what do I have to say about specifically B and C? What would I have to say about those things? The roots are what? What lives under them has to be what? Positive or 0. So 0 is weird. 0 is neither negative nor positive. So what lives under there has to be positive or 0. Okay, so even roots. And the reason I say even roots is because even though we encounter square roots the most, 4th roots are still an issue, 6th roots are still an issue. Okay, so what's underneath? I still didn't leave enough room. Has to say greater than or equal to 0. Okay, so those are red flags that we have to look for. Those are the only 2. That's the good news. So let's take a look at A. Does A have a red flag? Yes. In the denominator, right? We can't have it equal to 0. So what we're going to do is we're going to say, well, when would my denominator equal 0? Now, from what you saw from last chapter, we have options. We could use the quadratic formula. We could complete the square. We could factor and solve. I'm going to factor and solve. What could I pull out that they have in common? X. If I pull out an x, I'm left with x plus 1. Remember our 0 product property says if you have 2 things being multiplied together that equal 0, either thing 1 or thing 2 must have been 0. What would make this 0? Just this. Just 0, right? What would make this parenthesis 0 if x were negative 1? So negative 1 is off limits because it would make my denominator 0, and 0 is off limits denominator 0. So those two numbers are off limits. Any other numbers off limits for me? Okay, so we're going to write in interval notation. We can be negative infinity all the way up to negative 1. Can I include negative 1? Nope. Parentheses. In union with. So we're going to use some of those symbols from chapter 1. So here's our union. Union means combine it with. Negative 1 to 0. Can 0 be included? Nope. In union with. 0 all the way up to positive infinity. And this whole thing would be my answer. So this is my domain. Alright. Questions on A before we go to B? Okay, here comes B. What's the red flag with B? Square root. So we have, living under our square root, 16 minus x squared, and it has to stay greater than or equal to 0. 0 is fine, bigger than 0 is fine, smaller stuff isn't because we want to live in real number land. Alright. Ooh, does that look like a quadratic inequality from chapter 1 that we just learned how to solve with the table? Yes. Oh, look at math building on itself. Ooh, the front row's pumped. I'm so glad that you're that pumped on a Friday for quadratic inequality. Okay, I'm going to factor and solve. Notice it's quadratic, so I can deal with this by factoring, completing the square, quadratic formula, any of those things again. But it's going to work best if I factor because that's going to help me so I can think about the tables and what works and what doesn't. Okay, this is the difference of squares. Square root of 16 is 4. Square root of x squared is x. We're going to put a plus in one, a minus in the other. Remember, commutative property tells us it doesn't matter what order you multiply in. So my plus could be here and my minus here, or they could be flipped. It doesn't even matter. So what are my critical values? What would make it 0? Plus and minus 4 are my critical values. Now, I'm not going to make you draw out the tables. That's the good news. Okay, so that's kind of where we started. I'm not going to make you draw out the tables. I know, aren't you bummed? Okay, give me a number line though. On your number line, I need your critical values. So I'm going to put negative 4 and positive 4. Don't put anything else. Do you see how it divvies me up into these three regions? Kind of like we did before. Okay, so we need to pick a number to try. I'm going to try negative 5. Oh, I'm sorry. I'm going to try 0, and then I'm going to try positive 5. You don't need to make a full-on chart. Okay, let's try negative 5 first. This will give me, bless you, this will give me negative 1 and then negative 9. So if I plug it in, I'll get negative 1 times negative 9. Is that going to be a number that's greater than or equal to 0? Yeah, because it's going to give me positive 9. 9 is greater than or equal to 0. So that is a true statement. So this region is a go. If I plug in 0, I'm going to get 4 times 4. Let's see. Hold on. Oh, I see what I did. This should be a positive 1. I was going to say that shouldn't work. 4, and this is minus negative 5. Minus negative 5 is really what? Plus 5. So this is a positive 9. So this is negative 9 is greater than 0. Is that true? No. So this one is false. Okay, now we're here. We've got, if I plug it in, if I'm plugging in 0, I've got 4 times 4. And then the question is that going to be greater than or equal to 0? Is 4 times 4 bigger than or equal to 0? It is, right? So this was a no after further investigation. This is a yes. Let's plug in 5. 4 plus 5 is 9. 4 minus 5, is that going to give me a number greater than or equal to 0? No. Negative 9 is not greater than or equal to 0, so this is also false. So, can it be equal to 0? Yes, it can. So, close circle, because it can be equal to 0. You can take the square root of 0 and shade in the middle. So, -4 to +4 is my solution. So, you're still going to give your answer the same way. I'm just not going to make you make the full-on table. You still need to check values. You still need to figure out where your solutions live. They don't live here. They don't live here. But they do live between -4 and 4, and both -4 and +4 can be included. Part C has 2 red flags. What are they? A fraction and a square root. So when I think about x plus 2, if there was just a square root, so let's pretend it wasn't part of a fraction. If it was just a square root, I would say it has to be greater than or equal to 0. Agreed? But now if I remember that it's part of a square root and a fraction, what do I need to erase from what I've written here? So for this one, it's just going to be greater than. I can't be equal to 0 because if I am, that's going to make my denominator 0 and undefined. So what value of x? X has to stay what? Greater than or equal to -2. Can it equal -2 because it's a fraction? No. I'm going to draw my number line and I'm going to write my answer. So for this one, if we have x is greater than -2, -2 is the number I care about. Open or close circle at -2. Open. Then which way should I shade? To the right. That's where my positive numbers live. And my things that are bigger than -2. And then I'm going to write it in my interval notation. -2 up to positive infinity. And again, because it's positive infinity, you can put the plus or not either way. Okay, so those are the things we're looking out for domains. Last thing I want to talk about is example 4, and we're just going to do the first little part right here. This is the application piece where we can plug stuff in, which is what we were doing pretty much the whole time on the first page. The cost of feet in dollars of producing some yards of fabric is given by the following equation. So the cost of producing fabric is given by this equation. If we want to produce 10 yards of fabric, we want to know what the cost associated is going to be. So what am I going to do with the 10? Plug it in. So I have 1,500 plus 3 times 10 plus 0.02 times 10 squared plus 0.0001 times 10 cubed. And you can plug that all into your calculator in one swoop of things. You don't even have to do separate steps for all of it. So I can plug in my 1,500 plus 3, 10 in parentheses, plus 0.02 times 10, and this one's being squared, plus 0.0001, and this one's times 10, but it's being cubed. So I get $1,532.10. So again, this is an application where you could use it in the real world. So if I'm really making fabric, I know that I need to charge more than this, otherwise I would be losing money in my efforts to create fabric and sell it. And again, you could plug in different values to figure out what it would be for different amounts of fabric. Okay? Here we go. Assignment 1. We're going to start back over from scratch again. Some of the problems are going to be piecewise and plugging in. Some are going to be the evaluating where you're plugging in like a plus h and more complicated things. Some are the domains. And then I think the last one is going to be one where it's a like plug it in applications where